All right, and we are live again. Welcome back, or welcome, depending on who's watching, to the second part of the DiscourseDB tutorial. So we just finished the first part where we looked at the theoretical foundations, the concepts behind DiscourseDB, at a live demonstration of the data browser, and bread export, where you can edit and do annotations. And we got an introduction by Chris to the GitHub dataset. Now we are we'll have more of a technical focus, and we will have a look at the project setup, how the code, what the code looks like on GitHub. So in our GitHub repository, where the documentation can be accessed on GitHub, and then we'll look through the code in Eclipse and have a walk through the code of a data converter. So let me first share my screen again, and then we can have a look at the GitHub repository of DiscourseDB. So first I will ask Chris here if the stream looks right. So we'll have to wait for the delay. It looks good. I probably have to lock my screen too, so it won't go away. Let's see if that still looks good. All right, it looks good. All right, so let's have a look at the DiscourseDB repository on GitHub. So there is a landing page for DiscourseDB, that's discoursedb.github.io, but there's not much on it, but it leads you to the main repository. So you can also access that main repository. The link is here in the upper right corner directly by github.com by accessing github.com/discoursedb. So that's the main repository, the page with that lists the main repositories. So what are those repositories? Let's just briefly go through them. So the most important one is DiscourseDB core, and you can see by those charts, those bars, that this is the most actively used. Most commits have been made here. That's where actually most of DiscourseDB lives. The DiscourseDB tutorial workshop repository just contains data, code, and information for this particular tutorial. Also, it holds the contents from the first tutorial we had in January. So I will talk about this later when we get to actually get to the code. And we will also upload the slides to this repository, and this repository will also be linked to the tutorial page that is on the Dance web page. So we have a third repository here that says DiscourseDB schema, and what this contains, we can have a brief look, is a visualization of the schema that we saw in the slides, on the slides, for every version of DiscourseDB that we had. So you can really see how the schema developed, and it is a nice addition to what you might see in a database client. So if you look at a database client, you see your tables, but you don't get the good impression of how they relate to each other. If you visualize that automatically, you don't get the best layout for that. That's why we usually create, whenever the schema changes, a manually layouted visualization. So there's always a version as a PDF that anyone can watch, but also a MySQL workbench file that you can actually search and lay out yourself if you want. So this is the file that I had as a screenshot in the slides, and you can download this as a high-res version, and it shows you the different layers of DiscourseDB, and it is layouted in a way that you can actually see how those entities relate to to each other. So this is the schema repository, and there's not much else going on here except for those visualizations for each individual version. So we actually don't have one for the 0.6 final, the stable one. We will have to create that at some point. But the current one is the 0.7 snapshot. That's the code base we are using in this tutorial. Let's go back to the main page. We have two more repositories that don't matter too much. There's a demo that we developed for a workshop once, so it's probably not too helpful because it was based on an older version of DiscourseDB. And finally, the contents of the web page, of the landing page you saw. So the most important ones for you are actually the first three: the core, which is most of DiscourseDB; the workshop contents, which will hold the slides once we are done with this tutorial; and the code for the hands-on session, and the schema repository that holds the layouted database visualizations. Now let's go into the core. So here you can see basically subfolders, which each, most of them, not the assembly part, and but all the others, refer to a separate DiscourseDB module. DiscourseDB is a modularized multi-module project using Maven, Apache Maven, as a project management tool in a way. So tool for managing the dependencies and the interdependencies of multiple modules in a bigger project. I won't go into much detail what Maven actually does, but in a nutshell, it defines how the individual modules go together, how they belong together, what prerequisites a module has. So, for example, our data model is the prerequisite for all the data data converters. So the I/O modules, the folders with DiscourseDB I/O as a prefix, are all modules for individual data converters. Each converter has its own folder, has its own Maven module. And each of those modules, as we will see in a little bit, has the data model, which is the definition of all the entities that we looked at in the first session, as a prerequisite. So it needs to have access to the data model. So what modules do we have? So first of all, as I said, we have all the I/O modules. The I/O modules are projects or folders containing the code for a single converter each. So, for example, here we have a converter for the Bazaar chat. Here we have a converter. Oh no, that's a different one. Here we have a converter for the Coursera forum data. If we decided to also support other kinds of data from Coursera dumps, we would also put that in the same converter folder. There is here's the same thing for edX. We have the GitHub converter that Chris Bogart developed, and a few others. So as part of this third session, we're going to look at the edX one in more detail, but for now, let's stay here for a little bit to discuss the project layout a little more. There is a collection of projects with DiscourseDB annotation as a prefix, and that's everything that relates to the annotation interface that you have seen as part of the data browser. So everything that's necessary to export DiscourseDB annotations to Bread, to export and import to and from Lightside, and things related to the user interfaces. We have a project that holds basic functionality for a REST API that will be accessible from the web, and that's also the one that's being used as the main interface between the data browser and the DiscourseDB service. The low-level API that the data converters access are all located in the model folder. The model folder contains the lowest level of DiscourseDB in a way. It contains the configuration of the database server that is being accessed. It contains the entity definitions that we looked at, and it contains the services which constitute the API, basically, that the data converters and also the REST API have available. So this is, if you would reduce DiscourseDB to a single module, this would be the module that makes up DiscourseDB. That's basically where most of DiscourseDB is located. All the others are add-ons on top of that module class, module. And that's why this is basically a dependency in all of the other modules as well. There is one type of modules that we haven't talked about yet. We had the API modules. That's only one actually. The annotation ones, the I/O ones, and the model one. And there's also one with an ext prefix. And at the moment, it's only one of them. And the ext prefixed modules will hold external libraries that we had to adapt in some way. So basically forked libraries. Normally when we use a library, we would just add the dependency, add a link to that library so we can use it. We will see how that works with Maven in a little bit. But sometimes a library doesn't actually suit your needs completely, so you have to make a few changes, which you can with open source data. In that case, we have to fork them and host them in our repository, and those are the external libraries here. Now, this is the basic setup of the DiscourseDB code base. We will learn how those actually are wired together, but before that, let's look at where the documentation can be found. So each major and more mature module has its own main annotation page, and that's basically just the README MD file in the main folder of that module. So here, this DiscourseDB core repository already has a top-level documentation file, which doesn't contain much because we outsourced this highest-level documentation into a wiki, and you can find the link there. We will look at the wiki in a few minutes. So this top-level view always shows you the documentation for the module you are in. Let's look at one of the modules we have here. So ideally, a converter model. So let's look at the model we are going to walk through later, the edX one. If you open the edX converter folder, you will automatically see the README file that contains the documentation for this particular converter. For converters, we usually aim to, we haven't achieved that for all of them, but we usually aim to, oh, this is a bad example because this doesn't follow this, this layout. Let's do another one a bit, but I'll explain that first. We usually aim to define what the input into the converter would be, and how we map the source data to the actual DiscourseDB representation. We have done that for Coursera in the first session, so let's look at the Coursera one in here as well. Where is that? I/O Coursera. So first of all, you see what the data source is and how you would call the converter and what parameters you have to define. So in this case, starting the converter would require you to provide this list of parameters. So one is a name for the discourse, a name for the data set that you import, which in this case is just a single file. No, it's a database, I'm sorry. So the file would be the edX. So in this case, you assign a name that you for the data set you import, and the parameters to access the database that holds the data in this case. So Coursera, we import from MySQL databases, while edX we import from the JSON dumps that we receive from edX. Then we define the mapping. The mapping is defined in multiple visualizations here, which are then again described in more detail in tables that define in detail what of the source elements are mapped to what kind of DiscourseDB concepts. Furthermore, it also describes how we identify the data source. If you think back to the first session, we learned that data sources identify the location of a particular data point in the data source, and that you have to be able to interpret this this location identifier. And this is the description that documents how those IDs can be retrieved from the original source. And it describes all relations and all entities that are created as part of the conversion process. So we have looked at an example for the high-level documentation of a converter now. In the same way, we have these for other ones as well. So let's look at the Bazaar one, for example. That's a chat tool. Here you have, again, the source, which is the user interface, basically, because it's easier to illustrate how this looks in the user interface, and then how it maps to our DiscourseDB representation. The model also has documentation which explains most of the entities, similar to what we have looked at in the session 1 slides before. So those are the module-specific high-level documentation. So this is the module-specific high-level documentation, but it doesn't give you the big picture. So an overview what all the modules are. It doesn't give you information about how to set up your development infrastructure or how to get started developing for DiscourseDB. All this information we moved from this README. It was originally part of this top-level README file into the wiki. And the wiki you can find in the DiscourseDB core repository under wiki. It's here. It's also linked from the main landing page. There's, oh no. Oh yeah, there you can find a link to the wiki directly. So in the wiki you have a sidebar on the right, which has a few high-level documentation pages available for you. For example, a page for general information, so high-level information for setup purposes and configuration, how you configure DiscourseDB to access a particular database server that you have set up, and things like that. There is also a link to the document that I sent out as part of the invitation to this tutorial, which you can find here, which holds the instructions for setting up Eclipse and all the prerequisites, as well as how to check out DiscourseDB as a whole. So, furthermore, the wiki contains a list of documents, a list of modules that are structured according to their purpose, and links to documentation. The Java doc might be down at the moment because our build server kind of stopped working after we updated it last time. So it only leads you to a login, but this will be fixed soon, and you will get the updated Java doc whenever you click on that. So you won't have to log in. But that's not working right at this moment. All right, so that's all for how the code base is organized in our GitHub repository. And I would now continue with Eclipse and a walk through the converter for edX. So I did send out the instructions and the request to check out the code base. If you have done so, you can open that workspace in Eclipse now and follow me along. If not, it's not too problematic because you can simply watch me go through Eclipse and the code base. It will be necessary for later once we are at the point where at the point of doing the hands-on, but for now it's sufficient to have a view of my Eclipse. All right. So in the instructions, I showed what is necessary to do to make Eclipse work with DiscourseDB. The two main aspects that are relevant to make Eclipse compatible with DiscourseDB are basically to add the Git Maven connector that allows you to directly import Maven projects from Git. You could go without that and do both steps manually. First check out the Git repositories and then convert it into a Maven project and have Maven build that. But with this connector, it's much easier because you can directly say, I'm now exporting a Git project, importing a Git project as a Maven project into my Eclipse, and then Maven automatically starts building that project. The second prerequisite was, and if you're watching the recording now, you can go to this. Let me see, to this document in the wiki to see those instructions in the wiki. This setup instructions can be found in this document. The second main aspect that has to be taken care of is the installation of the so-called Project Lombok. That's a third-party tool that we heavily make use of in DiscourseDB, which takes care of a lot of boilerplate issues when it comes to objects that hold data. So we will see that when we look at the code base in a little bit. So you don't, in order to run DiscourseDB from the command line, just from a jar, from a compiled code base, you don't need to install or configure anything. It's just to make Eclipse compatible with what Project Lombok provides. And what that is, you will see in a little bit. So those two things are basically the only steps that need to be taken to be able to smoothly work with DiscourseDB in a modern Eclipse installation, and everything else is just checking out that code from GitHub. Okay, I go back to Eclipse now. So here in Eclipse, I have already checked out the DiscourseDB code base. Once you follow the instructions, it should look some similar to this. The only difference might be that I organized this view according to working set. So I just put all the projects after they were imported into a working set that just says it's a DiscourseDB set of projects. So this is basically the same set of projects we've seen in the Git on the GitHub website, and we want to look at the edX component in more detail now. So this is the way Maven projects are usually structured, and as I said, I don't want to go into much detail what Maven does and how Maven internally works. Maven usually has a source branch in the in the source tree, which is then structured with main and test, which under the main branch holds all the main code and resources, and under the test branch contains things that are supposed to run at testing time. So when you have, if you want to have unit tests, they would live in the test part of the source folder, and the actual code and the resources necessary for the code live in the source part of the code of the source tree, the main part of the source tree. So what's important is the actual is the project. So let's see. It was just, what does POM stand for again? Oh yeah, project object model. That's what it was. So yeah. So what's important is the POM XML file. POM stands for project object model, and that's the main component for Maven to or for you to tell Maven how this project is set up. So how this module relates to other modules in your code base, and how this module relates to external resources. Let's have a brief look at that. So I'll double click the POM XML, the project object model, and Eclipse already comes with a Maven plugin. So when you download a new Eclipse, it will always have that. That's why you see that XML file in this specific view. You don't see the XML, but you can always go to the raw XML as well if you click on that. But we will look at the structured view. So the most important thing here is actually the set of dependencies. The dependencies are the define the libraries that are necessary to run the code. One of them is a component from within our DiscourseDB repository, indicated by this little folder icon. So we have a dependency to our model module. So we require the entity definitions to be present in order to run this converter. That's pretty clear. What we use as well here, since edX comes as a JSON file, we use a set of JSON files and CSV files. We use this external library to parse those. If you have a different data source, like a database, you would add the database driver or the database library here. If we just have a brief look at the Twitter converter, for example, and look at the POM there, Twitter data, we have Twitter data in form of a MongoDB. So we would load the MongoDB driver as well as the Twitter external library as a dependency to this module. So this will simply have a list of the modules that of the libraries you want to use as part of your converter code. But again, it's a little out of scope to talk in much more detail about Maven. There are many tutorials out there that describe how Maven actually works in more detail. So to get started to develop for DiscourseDB, it's in most cases sufficient to look at the existing projects as examples, and sometimes it's also helpful to just copy one of them and adapt them to just exchange the code with what you want to develop. All right, so the main code for a converter lives in the main branch, the main Java branch, and here So here we follow a similar package structure for all of our converter projects. So usually converter contains of some kind of a data model that represents the source data, and a converter package that contains the classes that are actually called to start the conversion process. Let's look at those in a little more detail. So let's see, how do we get started there? So the converter package usually requires 3 classes. One class is the class that is actually called by the user who starts the process, which is the application. So in this case, we call it edX forum converter application. We always add the forum in this case because we anticipate that we will eventually import other edX data than the forum. That's why we add this forum subpackage and also add the forum to the names. So that's just a convention. So the converter application is a class that launches the the process and sets up the database. Now, let's see how. Yeah, I'll ask Chris here because he was he recently had to get into the nitty-gritty details of getting started with DiscourseDB. I've been around DiscourseDB from the first day, so maybe it's good to determine now how far back we should go with respect to what the technology requirements are, like Spring components. So, what do you think we should discuss about the technical process of setting up an application like that?
Yeah, I mean, it really depends on your background with this. I had never seen Spring before when I first dealt with this. I mean, I guess the surprising thing is that Spring goes digging through your code, looks for classes, and just sort of instantiates them if it knows you need something of that type. And so these on line 14 and 15, or line 15 in particular, it's telling it where to go to look for classes. And so, you have to sort of adjust that to make sure that it looks in all the right places for packages, and that's something you just kind of have to debug, I think.
So from what I've heard that people have done who got started with DiscourseDB recently is actually look at a couple of those examples and start out with a copy of those and adapt them for their purposes. So here it actually, it actually has the locations of where the main configuration is. That's always the same because that's part of the module, the model module that you imported as a dependency. But then it also needs to know where your service classes will be, which define what DiscourseDB API calls will be made. And we will see what the service class contains in a little bit. So a service class always contains calls to the DiscourseDB API. And this contains a link, a definition of the package that contains those. In our case, it's this package which contains the service class. And Spring will then look through the whole package to look for classes that are service classes. And service classes, we can just briefly open that up, are simply defined by a service annotation here. Any class with this annotation will then be discovered by Spring. So for any kind of data converter, the application, the starter class, looks pretty much exactly like this. The only thing that this class does is have those two annotations with a pointer to where the service classes are. In most cases, it's just one service class. And then it should assure that the input parameters that this converter requires are correct. So in this case, we simply just check if we have at least two parameters. So that's not a very safe check, but that's in this case what was done. And then it's this magic call in a way. So that's always the same for all these converters, and that's a Spring Boot concept. Spring Boot is a bootstrapping sub-project of Spring, which automatically takes care of configuring all database issues, all database connections, based on the configuration provided in the main model module, which we imported through this reference up here. What it does, it fires up a Spring Boot process, connects to the database, and then automatically launches the run method in any class that has a run method. So in this case, it's the forum converter class. So any class that is annotated with a component that has a run method is automatically invoked by this application starter class.
And
so
actually, can you go back to the
yes
converter?
Right, we have.
Okay.
We haven't officially opened that before. So.
Yeah, but just to point out something here, that when it's saying, auto wired here, this is where all this magic is happening. Is that you need these services, and rather than having to have code that instantiates them in all the right places, you just say auto wired, have the type of it and the name of it, and then when this thing runs, it's assembling all those things. It's grabbing the thing, instantiating it. You say if it's a singleton or not, or all these things, and the annotations just sort of bring it all together for you, so you don't have to do a lot of initialization code. So it's a little weird concept for me to get my head around, but it's very convenient once you start to understand what it's doing for you.
Yeah, so I think right now we can't really explain the Spring details too much for people who don't know Spring, but we can at least explain why we have those classes that we have there. So it's easier for someone who might then just look up how Spring works if they want to see that, or learn by example by looking at the existing converters, why we set it up that way. So,
but I'd recommend reading about it. It's hard to learn by example.
I don't see a way of making it much easier. So again, we have a class that simply starts the process. It just tells Spring to run to fire up an environment that has access to the database based on the configuration we provide. There is a default configuration that comes with the model module, so that's this one. This is in detail described in the wiki. So the model module has a default configuration that assumes that your database is available on your local machine. So this set of files in the model module contains all configurations that are assumed by default. And the database specific ones are usually the only ones that need to be altered. But don't worry, you don't have to actually change anything in the model module. There's another way that I will explain in a little bit. So this is the only one that contains properties that are relevant for running a DiscourseDB process on your machine with your database server. It contains a link to the credentials to access your database server. If you don't change anything, it assumes that you have a database server, a MySQL database running on your local machine with a standard port and a user with the username local and the password local. And it uses the database with the name DiscourseDB as a default. If this database doesn't exist, it tries to create one. So in most cases, those won't be the right settings. That's why you need to adapt them. And any project you want to use with DiscourseDB, in any project you can add the following file to your resources folder. A resources folder is a standard folder that comes in or is assumed in any Maven setup. So when you first create a Maven project, you will get that resource folder. In this case, we don't have this configuration file. That's why I will show you how to create that. So we are in the edX module. And in order to configure the database connection to something that fits your needs, you create a simple file that's called custom.properties. And this file will always override. Anything you put in that file will override anything that exists in any of those files. So it can be in the JDBC properties, or it could also be anything from the other configuration files that you can override with whatever you put in there. But in most cases, it's sufficient to simply override the database properties. You don't have to look at the Hibernate configuration, the connection pooling configuration, or the logging. This might be something you want to configure at some point, but that's that we don't have to go into detail now. So the JDBC. Whenever you redefine any of those properties in your custom properties, this particular property will be overridden, but the other ones that you haven't defined will still be used with their default value. So if you only want to change the username and the password, but you still have a localhost instance running on your machine, and you are okay with the database being called DiscourseDB, then you only have to redefine those two lines in your custom properties file. Simply put that in there, change the password, and change the username. Do you remember what the test account was?
Tutorial, was it?
Right. So we created, just for testing purposes, an account that you might use on one of our public servers, and the name is tutorial, and the password is, I think, DDB, yeah, DiscourseDB tutorial. So yeah, this is not localhost. So this is another location. The port is the same. So let's say, this database lives here. Port doesn't have to be changed, and we want to change the name because I only allow that database user to access a certain naming scheme. DiscourseDB next. So that's the database that it wants to use. So simply by providing a custom properties file in the class path of that project will override those properties, and all the other properties that are available in the model module will still be used with their default values. So you don't have to care what's actually defined in there. But normally you have to adapt the database settings. That's the most common change you have to make. So this automatically configures the whole converter to access a DiscourseDB instance at this location. At the moment, the default configuration is for DiscourseDB to create a new instance, a new database, a new instantiation of the DiscourseDB database schema if you provide a database name that doesn't exist on the server. It might be the case that in the future you have to explicitly create the schema in order to avoid accidental database creations or naming problems, but at the moment it's sufficient to simply define the name, and then it will create the database for you. Okay, so that's how to configure any project to use your database server. Okay, I think we just left off at the database convert, so the edX form converter application. So the converter application again starts a Spring Boot environment. The Spring Boot then looks for all component and all service classes. So any class that is annotated with component or with service. And what it then does, it takes care of instantiating the objects that are annotated with an auto-wired annotation. And that's a Spring concept that means that so since Spring takes care of establishing the database connection and managing transactions, Spring should also be responsible to connect a service method which holds the API methods, the actual method that reads data from the database or submits data to the database. It should instantiate those methods as well, because it has to take care of the transactions that are involved in carrying out those operations. In this case, we make use of the auto-wired part, which means that this object is instantiated actually by Spring. A similar concept can be found in the converter service, where we use a separate, where we use a similar concept, but we make use of the project Lombok here. So this really gets a little bit complicated, but eventually this is the same as you can see here. So here we explicitly say this is auto-wired, and we have something called field injection. That means we inject the instance for these objects into each field. So those two are fields for that class. In this case, we do something different. We do a constructor injection. That means we tell Project Lombok to create a constructor that accepts all required arguments. And required arguments are defined by any field that is uninitialized but not static. So in this case, we have those fields which we haven't initialized. So those will be required arguments if you instantiate this class. And what it then does, and that's a Project Lombok thing, it adds an auto-wired annotation to that constructor. So we didn't write this constructor here. You can find it in the code, but if you look at the available methods, you can see that there is a constructor, and that's in the background basically created by Project Lombok. And that constructor has as arguments all the required fields that are defined in here. And this additional annotation simply makes sure that there will be no that we won't end up in a case where this is not instantiated. It's not allowed to be null.
Can I ask why you didn't do auto-wired here?
So this would be a very long discussion. So
you can tell me later.
Yeah. So there is a thing that everyone right now in the Spring community says that field injection is evil, because field injection here might end up in a situation where you manually instantiate this class for some reason, and then you won't have this auto-wired.
I see.
So it doesn't force you to have Spring actually instantiate this. In this case, it basically makes sure that that all those are not null, and that they actually have to be instantiated when you instantiate this class, an object of this class.
Okay. Because
they are all part of the constructor, they're all required, and they cannot be null. So that's something that in the Spring community, so there are very strong opinions in favor of constructor injection rather than having field injection. Okay. Now, so this is the service. This is the converter. The application starts up the framework. It looks for components that have run methods. We only have one component, that's a converter. This one component has a run method. And this run method basically serves as the main method. That's simply the method that is launched as soon as the framework is ready. So what we do here is we simply parse the parameters that were passed to the main method here. So the framework will simply pass on the arguments that it received to any run method. In this case, we only have one. This run method receives those arguments again and parses them. So what we do in this case is we initialize the variables with the values from the arguments, and we load the data dump. So in this case, we check that the dump file is available and that it can be read. And in this case, we read an optional file that contains additional user mappings. That's something I briefly explained in one of the previous sessions. If you import data from multiple sources, you need to provide a mapping file in order to make the references, the cross-references, to make sure that you reuse the user entities that you have already created from a previous dump. All right, so once the data files are loaded, we can then invoke the actual mapping process. I have outlined briefly that it might be necessary to first create the entities that hold the posts, for example, the messages, the contributions, and then in a second phase create the relations between them. So what we first do is we read the input dump, which in this case is a JSON file. So we use the an external library for parsing JSON, and we call an iterator over all the JSON objects, basically. And what we do is each of the JSON blocks we parse into a data model that we developed that represents a single post, and that's what lives here in the model package. The model package holds a class that defines what data points make up a post. So each post has a set of data points associated with it that comes from the JSON file, and this post object holds the data for a single post. So what happens in the converter, that's source specific. So this is up to the developer of the converter to know how to split up the data into segments that can then be readily mapped to DiscourseDB. That's specific to the particular data source, in this case a JSON file. And we developed a parser that parses the post blocks in that JSON file and basically does a data binding for each block to represent the data in that block in a POJO, a Java object for holding the data. So, all right, so this is done once in order to convert the entities, the users, the content entities, and the contribution entities, and then we go through the dump a second time in order to the same dump in order to parse the relations between them, which we can readily then create between the existing entities in DiscourseDB. In our third phase, we read the optional file with the data mappings, but this is something we don't have to discuss here. All right, so Chris just has left the room, so I don't know if there are any comments at this point. I realize that there are lots of prerequisites in order to understand this, but I will do my best to actually explain that. So far, this the process involves setting up a Spring environment and dealing with the original data source, in this case a JSON file. We can have a brief look at how the same part of the converter looks like in a converter that uses something other than a JSON file. So if we go to the Twitter project, as you remember, I showed you the dependencies. In the dependencies, the Twitter data is read from a MongoDB instance. So if you look at the same part of the converter, we have the same structure of projects here, the converter project, and here we have the application, the service, and the converter class. If you look at the converter class here, we actually instantiate the database connection here, while in the edX part we instantiate in the edX part. Oh, where is it? Here. In the edX part, we loaded the data files, while in the Twitter part we instantiate the database connection. So the first task of the run method is to establish a connection to the data set. Here it's a database, and here it's a data file. Then, in a second step, we simply access the database and retrieve one data point after another. That's the same. That's the same aspect. That's the same concept as in the converter, where we load one JSON block after a time, one after another. All right, so that's the outline of what the starter class does and what the converter class does. Again, the starter class fires up the Spring Boot environment. The converter class opens the data source, which can be of any kind, file, database, and then it iterates over the elements in the data source and passes each element on to the service. And the service is the third part. That's actually what connects with the API. So anything up to that point, before we get into the service, doesn't really have a connection with the API, at least in most cases. In the service class, we now have the methods that deal with mapping from the source-specific object. In this case, it's a post. That's the object we defined here, a simple pojo that holds the data for a single post, that maps a post to the concepts in DiscourseDB. So this method is responsible for creating the entities that are relevant for a post. The method below does the same thing for the relations. So a post that we pass to that, pass into that method is will receive a connection to a related post. So we will see that as well when we go through the code. All right, so any question from you, Chris, maybe, or anyone online? So anything that you would have found helpful when you first got started with this recently? Because that would help me a lot, because I don't know what can be expected really from the general public and what is.
Yeah, I think you covered it pretty well. I mean, one thing that I remember surprising me a little was the model that you create these projos, these plain old Java objects that are really pretty simple. They just are a bunch of properties with a getter and setter, and it's just a way of holding, you're pulling in the data, holding it in this kind of pointless object, but it's just a different format, and then you're passing that on to the thing that pulls it back out and writes it to. So it's just an intermediate structure, but it's very explicit, so you know exactly what you have and how to convert it, and you sort of separate that off.
This is also not an absolute necessity, so you could actually just pass to the converter service every single data point that's required for a particular conversion process. So in order to convert to import a post, you could just pass the text, pass the username, pass on each individual element. But it's much better to have an object that encapsulates a post, or encapsulates a tweet, or encapsulates a forum, a chat message. So that's why we usually do it with a specific model that represents the data points in the source, and then we just have to deal in the service class with how we can then get from what's contained in that source specific object, how we can represent that in DiscourseDB.
Yeah, so essentially in the converter, you're reading in a file and calling DiscourseDB API functions, which we haven't even talked about yet, to put it in there. And all the rest of this, the service and the model, it's a set of conventions for how to organize this code. And it doesn't have to be done that way, but I followed it too, just to keep them all consistent, and it's fairly logical. So, but it's convention. It's a
right
design pattern that works pretty well.
So now, at the end of the first session, we discussed how we would conceptually map the discourse, the edX. No, well, it was the Coursera data. Well, we should have done the Coursera one then. The Coursera data to DiscourseDB, but eventually it's the same. It's the same thing. Just in the Coursera, converter, we read from a database, and here we read from a JSON file, which is not relevant at the point of actually mapping the data, because here we have an object already, so we don't have to care where this came from. Care about where this came from. So what we have to do now is to identify what elements are necessary to be created in DiscourseDB. So for a post, it is obviously a contribution that is involved. It is a content which holds the text for that contribution. It is the user that represents the author of that contribution. We need to have a reference to the discourse, because everything is related to a discourse. The discourse represents the where this conversation happened. And we need a discourse part that encapsulates all the posts that have been made in that particular forum. So all these are decisions you have to make when you first start thinking about the conceptual mapping. And this conceptual mapping is then implemented in this concrete method. And the way to do it is to use the DiscourseDB API. The API consists of other service methods. So it's the same concept as this service you are looking at right now, but it contains lower level classes that directly create or manipulate DiscourseDB entities. So those service classes live also, like the configuration, in the model module. So we can look at the package structure right here. So the model module has a core subpackage which contains the entity data definitions, which is the model package, repositories, which is an access layer to those model to those entities, and now what's more important for anyone developing a converter, the service classes, which basically constitute the API. Those are higher level operations that actually use repositories to manipulate data. So those are subdivided into the layers that we already know about: the macro layer, the system layer, the user layer, the annotation layer. So since we are mapping a post which involves discourse, discourse part, user, content, and contribution, we need both the macro and the user layer. So if you look at the classes in those two sub-packages, you will see the services that will allow you to access the database and create or manipulate entities of those kinds. So that's why we instantiate references to all the services we need as part of the conversion process. So those are the services we require for converting edX forum data. So it's the discourse part services, which gives you access to the database and allows you to create or manipulate discourse parts, contribution services for contributions, content services, data source services. We establish what data sources are. So this is for adding the information about where the data came from, user services, and discourse services. And so I guess I haven't thought about that in much detail. We probably can't just give a detailed overview of all the methods that those service classes contain. How did you get started looking into what the service classes provide? Did you look through all the services and see what methods they have?
Yeah, so I tried to get a sense of so I was a little confused at first about the difference between a repository and a service.
No.
And what a conclusion I came to was it was just sort of a level of abstraction. That the repository is closer to just find and retrieve a field,
right.
Find things by this that match this. Services, maybe pull together a little more, a couple different objects or something.
Right.
I don't know. Maybe you can state more clearly what the difference is. But
yeah. No, that's pretty good. So the model itself simply defines the definition of the entity. So the contribution model contains the fields that the contribution will have in the database.
And they don't do anything.
And the relationships between this contribution entity and other entities. So that doesn't do anything besides defining those. The repositories are a low-level access structure to those fields. Those simply define what the operations are you can perform on those fields. So are you able to delete that particular field? Are you able to search for an entity by providing a certain set of fields? For example, is it do you want a method that allows you to find users based on their first name, or users based on their last name, or first name and last name? So this the repositories define low-level operations on single entities and their fields. Single entities is important. A repository usually has a one-to-one relationship to an entity. You usually have one repository per entity. The entity is the data model. The repository is the interface that allows you to interact with the data model. And then you have the service, and that's what you would use to interact with those. The services then use the repositories, because the repositories define the entity level interactions, and then encapsulate processes. So for example, you want to, let's see, what's a good example for a process that is defined in a service? For example, contribution service. Let's see, let's just go through that. Right, for example, create a discourse relation. Creating a discourse relation involves actually three entities. Two entities of the contribution type and one entity of the discourse relation type. This will involve the repository for contributions, and it will involve the repository for discourse relations in order to give you access to those entity types, give you access to operations on contributions and operations on discourse relations. But it then encapsulates the process of actually linking those two contributions with a discourse relation. So you don't have to actually call all those operations in the repositories. You simply call this single service method, provide the two contributions, and the relation that you want to have between those. And in this case, it's enough to just define the type of that relation. What it will then do is it will create a relation of that type, and it will relate that relation to the related contributions. So this is a process that uses repositories to manipulate entities within a single transactions without you having to deal with how this is done on the database level. So those are the differences between models, repositories, and services. And as long as there is not the as long as you don't need an operation that doesn't exist, you never have to worry about repositories and models. Only if you have a task that you cannot solve with the existing service method, you would have to think about how you would represent that through repositories. So that's the that's how this multi-layer framework works, really. Then there are, so once you get into the REST world, you have yet another layer on top of those. So there are then things that would either expose repositories or expose services. So depending on your needs, but that's something we won't talk about today at all. So exposing data services through REST APIs are a different story. So this, what we look at here, only relates to accessing DiscourseDB from within a Java environment. Okay, so where did we stop? I kind of lost track of our train of thought here. So the last thing is we were in the so we were in the service method and the service class, and we started thinking about what concepts are involved in mapping a post, and then we looked at the service classes that would allow us to create or manipulate those concepts, those entities. And yeah, if you have a suggestion how we would best illustrate how this works, because without knowing those data services.
So a lot of these services you can kind of guess by the names, and actually some of them are generated automatically, like this find one by data source function being called in the 4th line of this function. I don't know if that one, but ones like that, they're actually declared in the interface, and there's no code written, and it automatically generates the code for it, which is really cool.
That's on the repository level. That's true. On the repository level, it is, and yeah, that's maybe also just as an aside. That's a Spring Data. Spring Data is a sub-project of Spring that makes it easy to do data processing with Spring, and it allows you to simply define with a well-defined naming scheme to define a method signature in the interface, and get from the framework the implementation for it without actually writing it. So there is a naming scheme that defines what find one mean, and then by some field. Then you could define as the signature for find one by data source, or by, for example, if you want to find a user, you could define the method signature find one by first name and last name. And this would automatically create the implementation for a method that finds a single instance of a user entity that has the first name with the value that you pass to it and the last name with the value you pass to it. So this, if you have simple queries, this allows you to define those queries in code without actually implementing them. There are queries that have to join over multiple entities, and those have to be actually implemented differently. But any queries that only work on a single entity can be simply defined in the repository for that entity by only defining the signature of the method. And that can be a find method, a delete, a store method, an update method. So there's a whole a whole scheme of method names that you can define in order to get the auto-generated methods.
So, but and a lot of these already exist. So that's something I found when writing the GitHub one, that there were a few of them I had to go in and add, but mostly everything was already created because it had been done so many times. So I guess the other interesting thing is to walk through this and see what objects are being created. Where does the transaction actually start? The database transaction, is it at this function level that you're looking at?
Yeah. So let's see. So what we see here is we have an annotation on the class, and it says transactional. Propagation is required. I'll tell you what that means, and read only is false. That means since this annotation is on the class, it will automatically be added to any public methods in that class. So you can basically assume that any method has this annotation. So that means that any annotation runs within its own transaction. However, if one method calls another method that is also transactional, since the propagation here is required, it will propagate that transaction. So it will basically pull in the other method into its own transaction. So it will create one transaction at the point when you first started a transactional method. And read-only false is simply is not really required, but so it's assumed to be false normally, and I tend to redefine it on a method if it's only a read method, because it can be it sometimes gives you a better performance if internally it can assume that it doesn't have to lock tables since it's only reading. So if you can actually redefine every method to set this read-only value to true. That means that Spring isn't locking anything when this is run, because it's only reading, or the locking behavior is at least different. All right. Okay. So map entities. Okay, let's just briefly step through that. So what I do first is when I call the map entities method, I provide a post and I provide the name of the data set, and I check if those two parameters are actually set correctly. So the post can be null, and the dataset name has to have some text in it. What I then do is I check in the database if I have already imported earlier at some point a post with the same data source. So the data source for posts, for edX posts, are defined by the edX ID, the ID of that post. So we look in the database for a data source that has that ID of that post that we want to import now. If that already exists, we create a warning and say we have already imported that in the database, and then we jump out of that method because we don't want to import it again. So that's just something you might want to add if you assume you could have like iterative updates that contain multiple entities twice. So yeah, that you don't end up importing the same thing several times.
And actually, in my GitHub importer, I don't do this because I'm importing some very, very large files, and it just slows things down to do so much checking. And so I sort of assume that I'm going to wipe the database and re-import for now.
All right.
It's just, yeah. So that's an efficiency trade-off.
So in the particular case of edX, we had the case that we got new data every week from edX. So we want, but that was always just an augmented, an updated version of the file. So it was not just the part that wasn't available before. It's just the bigger file with the new stuff in it.
Really?
So instead of actually looking in that file for the stuff that's new, we simply added that check to only import what's actually necessary. So then we have some logging messages, which just make it easier to keep track of what's going on in the console. And at first, we then want to get access to the discourse, because, as we said, everything we do is connected to a discourse. So the discourse service provides a method that is called create or get. That simply means that if we call that, and that discourse that we want to get access to doesn't exist yet, then it creates one, stores it in the database, and provides you with access to that object in your object here. If it did exist before, it retrieves that from the database and fills the object with the values from what it has just read from the database. So after this call, you are guaranteed to have a discourse object that is consistent with what you had in the database before. So in the case of edX, we have the course ID as a unique identifier of the MOOC, and use that as the name of our discourse. The next thing we want to do is we want to get access to the discourse part this post is part of. So as you know, we use discourse parts to aggregate multiple contributions. So a discourse part can represent a forum, and a discourse part can represent a thread. So that's why we first need to get a discourse part that represents the forum. So we simply define the name of that forum, since edX only has a single forum that doesn't have a particular name, in contrast to Coursera that allows multiple forums that have explicit titles. We simply name it with the course ID, that's our discourse name, and add a forum onto it. So it just has to have a unique name. So that's the discourse part that represents the forum. And we assign a type for the discourse part to identify it as a forum. Then we actually get started with the contribution. For some reason, this actually checks again if that contribution was already created. I don't know why there are two checks in this case, so this might not really be necessary. So this is probably something that happened in some refactoring process. So this is actually duplicated. So what we do is we first check if the contribution already existed. That's what we already did here. So this should be removed. I should actually create a to-do marker. That we get rid of that. And if it is not the case, so that's a Java 8 construct, so I won't go into much detail. So what it does, it retrieves the data source that belongs to that contribution, and if that actually exists, then it doesn't do anything, or else, if it doesn't exist, it performs the following code. And what do we do here? So if our contribution didn't exist, we want to create it. So at first, we want to define what type the contribution is. As you might recall, we define from the session 1, we have contributions that are thread starters and contributions that are comments. So we first, or posts, right, those three types. So we first have to determine what kind it is. And that we can simply get from the object. The object knows what type it is. So once we know what type it is, we create a content entity. A content entity can be created by calling the create method in the service. Once we create it, so this instantiates a content object and creates it in the database. What we can then do is we can fill the fields of that entity with the values we wanted to have. So a content entity has a text field, and in the text field, we store the body of the post. A content entity has a start time, which is when it was created, and we fill it with the timestamp from the post object. And a content has a user, an author that we fill with the current user. We kind of skipped the user part in here. And then the content has to be associated with a contribution. That's why we create a contribution of the type that we determined earlier. Fill the fields. The current revision is the content we just create, and the first revision as well, because we point both links to the same content, since we don't have a revision history for those posts. We fill the start time. We fill the number of upvotes based on what the post says. The post gives us access to that information. And we add a data source. The data source is how is the information that allows us to identify that post in the original source data. Right. So let me just see. Oh yeah. So what we have at this point is we have a contribution for our post. We have the content for the post. The content and the contribution are associated with each other. What we finally have to do is we have to add the contribution to the discourse parts it belongs to. The discourse part belongs both to a thread and to a forum. So this is what happens in the last part. So we add the contribution to the thread, and we add the contribution to the forum. Right. This happens here. Contribution to the forum, contribution to the thread. And this basically concludes the mapping of a single post. What we skipped here is the user information. So before we create the contribution and the content, we also have to create an instance, an entry for the user. And the user is in that data set only determined by its username. So we get from the post the name of the author, and we create a user with that name. And the user is associated with the discourse that we instantiate in the beginning. So to reiterate, first we check if the user, if the contribution already exists, which is kind of duplicated here, but that's an issue with that particular implementation. We establish, we gain access to the discourse object if it didn't already exist. For example, if that's the first post we import, we have to create it, otherwise we retrieve it. Then we create a discourse part that represents the forum. We create a user entry for the author that we identify by the author name in that post. And then we create contribution and content entities holding basically the payload of that post, and associate the content with the user that represents the author. Finally, we add the contribution to both the thread, the discourse part representing the thread, and the discourse part representing the forum.
I have a question.
Yes.
At the end of that, why do you add it to the thread only if it's a thread starter? Are other posts still part of that thread?
So let's see.
Seems like you'd want to trace a post back to the thread starter, find out its discourse part, and add it to that thread too.
Yeah, that's true. Yeah, I don't know right now why.
It may be that the way we're using it doesn't matter in this case, but
yeah, I don't know at the moment.
okay.
Yeah, we just added the thread thing because the edX doesn't really have a thread structure,
Okay.
and we only added the thread discourse part because it would otherwise look weird in the data browser. So that's why it's basically, so if you look at edX data in the data browser, most threads only have one contribution, unless you have a comment on a post, which only happens very rarely, and then the thread has two contributions. But I don't know why that is the case. Okay, so this is how a single post is imported into DiscourseDB. The second method would then run in phase 2, when we read the data set again and establish the relationships between them. Because in order to connect one post with another post, we have to make sure that both posts have already been imported. And since the sequence of data in the data set, in the source set, is not always assured, we'd rather read it a second time to make sure that we actually have all the data so we can establish the relationships. But conceptually, this doesn't add much additional information to what we have seen in the mapping of a single post. So I have the feeling that things might be a bit too complex without knowledge of the frameworks used in order to get into development right away. So what do you think we should do next? So we have looked at an example of a converter, what elements it contains. So to reiterate, it has a project object model that defines relationships to the libraries that are used. It has a converter package and a model package. The converter package has an application class that fires up the framework, a converter class that is responsible for reading the data set and iterating over it. And each element that it iterates over is passed to the service class, which is then responsible for mapping each of those elements to the concepts we have in DiscourseDB. And this is done by calling the service classes, which are instantiated in the first place by the Spring framework that we fired up through Spring Boot, which does its magic with the run method and the dependency injection by looking through the class path for classes that are annotated with component and service annotations. And in order to make all of this work with your database, you need to provide a custom configuration that overrides the default values for at least the username and password for your database, the host name, and the database name. Anything that's not overridden will be used with its default value in the model module.
Yeah, so I think what you've said and having these as examples is probably a pretty good start. I think that somebody would be overwhelmed without understanding Spring, because I know I was when I was at this point. But I think it's possible to take one of these as a template, just copy it and change things, and think about it and ask questions and get there. So it's probably a question of what Chris and Ren are interested in doing today, what their short-term goals are, or
So what we have in the tutorial, maybe let's have a brief look at that. In the tutorial repository on GitHub is what we have prepared there, and I assume it's a bit out of scope to actually do that activity now, because that's just the feeling I have. What we've prepared there, and this is something that people even watching the recording might want to look at, is a sample repository, a sample project for a converter for the GitHub dataset that contains the basic scaffolding for one of those converters, meaning it contains the converter, a package with classes required to set up one of those, to start up one of those converters, and the object model for the domain model for the GitHub dataset. So we can see here that the package with the converter classes, we have the 3 classes that we introduced. The application class is already implemented. It doesn't do a parameter check, but it fires up the the Spring Boot environment, which connects to the database eventually. It contains the class that takes care of reading the source data. A data sample is provided in the resources folder, so once it's checked out, it should work right away. And the only thing that has to be done is at the point when you when you iterate over the entities in your source file, you need to pass it on to a service method. So you get your GitHub issue comment, which is the domain model for the GitHub dataset, and now something has to be done with that. So this has to be passed to a service method, and the service method that lives here still has to be implemented. So that's basically what we have seen in the edX example in this class. So the method that actually does the conversion from the domain model to DiscourseDB, that would have been that has to be implemented in this hands-on activity, and we provided a solution as well. So anyone who wants to try to implement a converter for this data set, and again, the data set is a sample for the data set is here. So those are files from GitHub that you would have to import. And if you want to get started with that, you can use this project framework for your converter. And if you are stuck, there is a solution in that repository in this answers don't peak one. So this has the actual final implementations for both the converter, which calls the service class, and the implementation of the service class here.
And that's just one possible solution. There's a lot of ways to map it. There's a lot of choices about what you could do or not do. And these are a partial implementation that has further exercises as comments in them. So, you know, you could take it further if you want.
Oh, this still says first. Just, that doesn't matter. Let me just briefly. Second. So there's a branch of that repository that actually contains the data from the first tag day. Oh, this has changed already. It's just the headline that wasn't correct. All right, so maybe we can now wrap up with questions about any of the sessions today. And if actually requested, we can go into any hands-on activities as well. But at this point, I think the overview part is over, and it's really just up to anyone participating what we should cover.
I enjoyed that.
So maybe I will just stop sharing for now so I can also look at the Hangout, wherever that is.
I have to bow out.
Where is the?
That was a nice overview.
Oh, there it is.
The code.
Okay, good. So, Ran, are you still there? It's pretty late there, I guess. Is there anything you want to cover while we are here in this Hangout? We can, of course, you can just also get back to me. I'm actually leaving CMU Wednesday next week, so I'm still not out of the world. So I'm still staying in Pittsburgh, and I can answer emails, so there's no problem. But Chris Bogart here will take over, and there will always be someone that you can talk to. And if there's nothing we to discuss in this Hangout, we can actually conclude now. So
So you're leaving?
yeah, so I'll answer any personal messages in the chat once I stop the broadcast. So all right, so thanks for participating. Also, thanks everyone who watched the recording for watching. And if you have any questions, the GitHub repository will always point to someone responsible. And oh yeah, so maybe, well, I'm not sure if anyone that watches the recording will watch up to that point, but there's also a license attached to DiscourseDB now. It will be GPL2. So the license of DiscourseDB in the future will be GPL2. So that's news. All right. So thanks everyone, and have fun using DiscourseDB.